All right, so scientific notation. Scientific notation is basically used in science because you deal with numbers that have tons of zeros or that are so teeny tiny that you have lots of zeros before the actual numbers, like 0.00000 forever. And to kind of save yourself the trouble of writing all those zeros, that's what scientific notation is used for. So scientific notation looks like you have one thing, one digit before the decimal point. Then a certain number of digits has to do with what is called significant figures. In other words, how precise you can be. Anyway, that comes far away from now. So all you need to know right now is that a number written in scientific notation will have one digit before the decimal point, a few digits after the decimal point, and then you multiply it by 10 to a certain power. So that certain power, as you remember from yesterday, that n can be positive, can be negative. Let's look at the first example. So we have 12,000. I'm going to move the imaginary decimal point that's at the end right now 1, 2, 3, 4 times. I mean, you literally take a pencil and help yourself visually. I move it 4 times to the left, which means that I just made this number 1.2. That is 10,000 times less than what it was before. Then I have to multiply it by 10,000, and 10,000 is 10 to the 4th. Now, the next one, again, imagine the point right here, move it 3, 3, 6 times. Small numbers. Remember when I explained to you how centimeters and meters work, I gave you this mnemonic: small, big, small, meaning the power of 10 is negative. So let's look at this one. Scientific notation, again, means something meaningful, decimal point, and whatever. So in our case, I'm going to move my decimal point over here, and I'm going to say 4.0 or just 4. 4 is fine as well. Scientific notation can also be just the number 4 times, and I moved my decimal point 4 times to the right. So I made my number 10,000 times greater. Then my scientific notation will look like this: 4 times 10 to the negative 4. And if you want to check whether you're correct or not, so you write 4, then grab your decimal point and 1, 2, 3, 4. 1, 2, 3. So there you go. Then we are correct, aren't we? Great. The next one. Here you are going to move your decimal point to the right also, but only 3 times this time. So we're going to have 3.5 times 10. You moved it 3 times to the right. Your power of 10 is going to be 3 times to the left, because remember, negative numbers are like going to the left. You can do the next one yourself. Then the next example is we need to convert numbers. So what is 10,000 times 10 to the 4th? I need to write this in scientific notation. Scientific notation is 1.0 in my case, or I can just do 1. That gives me 4, and that's already a 4. So it's going to be 1 times 10 to the 8th. 1, 2, 3 to the right, so I can say it's like 3 times 10 to the negative 3 times 10 to the 5th. Add these two together, end up with 3 times 10 to the 2nd. Now you can do the next ones, I assume. I'm actually sure that you can. When you have to multiply or divide in scientific notation, do not confuse this with something like 2 to the 2nd times 2 to the 3rd equals 2 to the 5th. In that case, I had the same base. Here, you don't have the same base. You actually have different numbers. What you do care about is the numbers themselves. So I have 1.2 times 3, that's 3.6. So you deal with that separately, 3.6. And then also separately, you're going to look at your powers of 10. So I have 10 to the second and 10 to the fifth. That gives me 10 to the fifth. So again, you separate the meaningful numbers, deal with them separately, and then you do the powers of 10 also separately, and then bring them together in one number. You can do the next one, and I'm going to look at the division, which is number 3. So here I have 1.2, 10 to the fifth, divided by 2, 10 to the third. So I'm going to look at these. 1.2 divided by 2 is 0.6. So it's 0.6. Now 10 to the fifth divided by 10 to the third is 10 to the second. So 0.6 times 10 to the second. There you go. Or you can actually write it like 6 times 10 to the first. Or you can just write it as 60 if you want. That's fine as well. Because 60 is not that hard. I mean, 60, see, it's not longer than that one. And again, scientific notation is used so we don't have to write all those zeros. All right, the next one, 3.5, 10 to the 8th. Again, you're going to look at this separately and then deal with that over that. Be mindful that we have 10 to the 12th in the denominator, so your answer will have a negative power of 10. And adding and addition and subtraction. I don't know English, sorry about that. So adding and subtracting in scientific notation. So here, what is very important is to make sure that you have kind of the same denomination. Because if I say that I have $1 and then I have 1 cent, is that like that? Whatever. So I won't be doing 1 minus 1 equals 0. Because $1, if I have 1 as a whole for dollars, then 1 cent is actually 0.01. So be careful. The first thing you need to check is whether your denominations are the same. So in my case here, they're both 10 to the fifth. Since they're both 10 to the fifth, then I can take care of the numbers, the meaningful numbers. 8.2 minus 1.4. So that's going to be 6.8. So my answer is 6.8 times 10 to the fifth. If your denomination is different, like here, I have 10 to the third and 10 to the fourth. What you need to do, you have to make them in the same order, in the same denomination. Dollars or cents. So the options for number 3 are, I can either say it is 1.2, 10 to the third, plus, and I'm going to make this 10 to the third, so I would cast my 10 to the left, lower. Then I have to move my decimal point to the right. So I can say it's like 7 times 10 to the third. And that will give me altogether 8.2 times 10 to the third. My other option is to actually bring this one higher. So if I move that to the right, then my decimal point needs to move to the left in the meaningful number, and that will be 0.12 times 10 to the fourth plus 0.7 10 to the fourth. Together it will be 0.82 10 to the fourth, which is exactly the same as the one above it, because these guys are equal. So go ahead and complete the rest of them. And when you're done, you can check the answers.